So our next presenter is Jochen Köhler. He leads at ZF Friedrichshafen in Germany. He leads the Department for Autonomous Driving and ADAS Simulation. In the Z-level project, he is lead of the part of the simulation-based and virtual development and testing. And today he will speak about architecture and its impact in the Z-level founded project. Jürgen, please, it's your stage.
So thank you very much, Verena. No problem. This was not the first time. So thank you for your kind introduction. Nice welcome also from my side. I will talk about architecture. A lot of people worked for this presentation. I want to give a special thanks to Heinz, who prepared the most of the slides. I'm just presenting those. So let's start. So when you build anything, for example, a house, you will not do this from scratch. It's always a good idea to use blueprints and make an architecture about it, and you will not start from scratch. So you will use existing blueprints, you will use existing patterns, and what helps a lot when you build a house is also using standards, like for plumbing, to connect the things, and also on electrics. It's nice that you have standards and everything is working fine together. And we can use the same analogy also, of course, for simulation. If you think of, you have built one simulation model here on the left side that used in project A, and it was built for this environment simulation A. Of course, you adapted the interfaces to this project, and then you want to reuse the same simulation model in project B, but there is another environment simulation with other interfaces, and then you have a problem. And this is the usual way how we work today in automotive industry when we exchange simulation models. So what is clear is without any standardization of structure and interfaces, the reuse is not that simple as it could be, and this is what we work on. And here you can see a flexible and modular scenario-based simulation architecture. And as we do the scenario-based simulation, we always start from the scenarios, either logical, or when we go to the simulation execution, it will be concrete scenarios. And in these concrete scenarios, we have two parts. The one is how to the environment in which the ego vehicle is driving is parameterized and described, and then the ego vehicle itself. And of course, as we go more into detail in the ego vehicle, in the system under test, we have a more or less complex architecture within this ego vehicle, and this architecture consists out of a lot simulation components. And this has also to be described in a way, and we try to do some standardized interface architecture. So we say we have a certain topology that we want to use, and we standardize in special the interfaces between these components. And we do this, as it was mentioned already, by a standard that is called System Structure and Parameterization, coming from the Modelica Association, and most of you will know the FMI standard, the functional mockup interface that is also defined in the Modelica Association, where you have pretty nice definitions of the interfaces and parameters of each project. And what I want to mention also here is that we have some interrelation, of course, between this environment and your ego vehicle. We will come into this later on. I just want to mention it for the later slides. Okay, so this is one dimension of the architecture regarding the simulation model itself, but on the other dimension we have a simulation architecture for the tool itself. So it makes work very easy, or much easier, if different tools have at least similar architectures, because as I mentioned already, you have a relationship between the scenario description and you have to control the scenario somehow, and on the simulation models that have to execute the scenario behavior that was described here. And this is a generic architecture we worked at Z level for the simulation platform. You see here at the right top the scenario generator for example, criticality analysis, and then the control of the scenario. You see the simulation core, where the simulation models were built and executed. You see at the top left the test object, where you define what has to be tested, and then on the lower side you see a lot of repositories regarding simulation models or extensions for the simulation and so on. This will be described much more in detail in the stream 1 of the demonstrators and concepts at the evening. So if you are interested in these things, please visit the stream 1. I mentioned the standardized interfaces already for the simulation models. We tried to build and generate a generic architecture, but of course it cannot do this for any use case and for any application. But what we are focused at was to improve and enhance the existing standards to define the interfaces. And one example, of course, is OSI from ASAM. Where we can define interfaces, especially for two parts of the simulation. One is what we call the traffic agent or the traffic participant. This can be either the eco-vehicle itself, or it can be any traffic participant on the road or on the sideway or what else. There we did some extensions, and this is also described in the stream 3 of the demonstrators and concepts. And the second part where we worked hard was on the sensor side, of course, because this is the most complex thing in simulation here. And we did already some improvements in the sensor models. So far, we are focusing on the object-based sensors, but in the second half of that level, we will concentrate on the reflection-based sensor models. So if you want to learn more about how we improved and used the OSI, please visit the stream 2, also in the demonstration and concept stream at the evening. Okay, yeah, just as an outlook for regarding the tool architecture, we have a so-called research implementation that was built by or is developed by DLR. Where already some of the components or the most important components are implemented already. I just want to mention it here. I will not go into detail, but just also to have a link here. It's once more the stream 1 of the demonstrators and concepts, the automated simulation of scenario sequences presented by Danny and his colleagues. So just a very quick overview about the simulation use cases. For simulation use case 1, for the criticality analysis, we use this simulation architecture for the simulation model. You can see it here. Basis is the open source tool OpenPath. We use some simple camera sensors. We use the driver models and so on. And this was already embedded in the simulation platform architecture as I described. And once more, this will be shown in detail in stream 1 of the simulation use case this morning, called closed loop traffic simulation for criticality analysis. And this is the second stream for the closed loop simulation. There we did the same thing with more focus on simulating the complete vehicle with the sensors, with the vehicle dynamics, with the HUD function itself, and as closed loop, so you can see how the vehicle is reacting and also the environment is reacting. And here the interesting thing is that we did this with commercial tool vendors. We have 2 implementations with IPG and with DSpace, and this will be presented at the stream 2 this morning in simulation 2. And last but not least, the simulation use case 3, where we focus on sensor models. There at the first step, we focused on the camera and LiDAR sensor, and we took also the defined sensor interfaces, what I described earlier, and put it in some commercial tools and simulated here in more in detail these sensor models. And this is the stream 3 in the simulation use cases, an open loop simulation for integrated testing and validation. Okay, so now we are already at least almost at the end. Conclusions. We have successfully built up some reference architectures, and we can show that this is working for all of our simulation use cases, also together with our research implementation and with some commercial tools. We gained knowledge in the OCI standard, and we did already some improvements regarding the traffic participant, the traffic commands, traffic updates, and some details in the sensor simulation. What is the outlook for these architecture things? We want to focus in the second half of our project to simulation parameters. That is also more or less an architecture thing. So we have to parameterize the scenario, the static scenario, our simulation under tests, and so on. So we will work on this, how we can standardize this. And we are also working on how to modularize the scenario engines that are executing the descriptions of the scenario. So we have a quite nice approach here where we can read in different scenario description formats like Open Scenario 1 or 2, put this in the middle and bring this in a more abstract data model, and then we can convert it to the target platforms, for example, OpenPath or any commercial simulation tool, or what is also what was also mentioned already, AS Mini. And this is quite a nice approach here, of course, for research things, so we can try out very fast new features of any scenario description. And already the last slide, another focus, as I mentioned already, now we worked on the object-based sensors. In the second half, we will concentrate on what we call the refraction-based sensor models, where we will bring in all the ray tracers, the renderers, the 3D geometries, the materials, and all of this stuff for outside and inside the sensors. Okay, this was it regarding architecture, and now I'm happy for questions.